Since the last video, I've written a GUI to make the exploratory function of the device easier to use. It's in the software distribution in GitHub and it's GUI.py. Let's just get that running. Okay, so on the left you can see there's an image of a ZIF socket, and on the right hand side there's a text console that shows any comms going between this program and the Arduino backend. So either side of the ZIF socket there's a set of drop downs which allow us to choose whether we want to set up an input signal onto that pin, driving the pin on the test chip, or whether we want to set up expectations for the outputs that are coming from that chip, or whether we don't care, or whether we want to apply certain tests to the chip. Up on the top left, we can choose the COM port that the Arduino is connecting to, COM6 in this case. Now I'm just going to put a 74245 transceiver into the socket, and the 74245 has got 20 pins, so let's choose 20 pins. That just has the effect of labeling the pins on the ZIF socket here conveniently. Now if I didn't know what chip was in the socket, I could run the identify function. And what we can see is the Arduino goes off searching through its database of chips for a device that matches the thing sitting in the ZIF socket. And thankfully it stops at 74245. So it's definitely a 74245 that's sitting in the socket. We could also use one of the test functions. Now each time I run this test, we can see the values coming back on the ZIF socket are sort of changing randomly. And that shouldn't be too much of a surprise given that we haven't actually set up the power supply to the chip that's sitting in the socket. So let's just do that. So pin 20 is 5 volts and pin 10 is ground. Now as soon as we do that, we can see that the pins on the right hand side of the device have gone to high impedance and the pins on the left have gone to a low. Pin 19 of this device is output enabled, so let's set that to a definite value. Let's enable the outputs. And pin 1 is a direction, let's set that to 0. Now with that particular setup, the 74245 is configured so data is flowing from the right hand side of the device to the left hand side of the device. So if I change the input here on the right, let's say to a logic 1, then we see the output on the left, pin 2, go to a logic high. Likewise, if I set that to a 0 on pin 17, then there's a reason why pin 3 has stayed as a logic low. Now what I could do is I could set expectations on those pins. I could say, well, I expect that to be a logic high. I expect this to be a logic low. I could also say I expect a pin to be high impedance, which of course in this case it's not, it's a logic low. So pin 4 is a logic low, I've said I expect a high impedance, and so the pin is highlighted as red. Pins 2 and 3, well, they met their expectations, so they're green. And of course, if I were to turn off the outputs by setting the output enable high, then we can see that the pins on the left have all gone to high impedance, and now pin 4 is meeting its expectation. Let's just turn the outputs back on again. And let's clear these settings over here on the left. And let's clear these inputs here on the right. So what do we expect to happen if I flip the direction pin to a logic high? Well, of course, all the pins on the left have gone to high impedance and the pins on the right have gone to low. So now the data is flowing from the left-hand side of the chip to the right-hand side of the chip. So I hope that gives you an idea of how to use software. I guess it's an alternative to putting a chip into a breadboard and fiddling around with wires and LEDs and whatnot as indicators. And the project's really delivered on what I was hoping, which is I've got the device I wanted in order to test the chips that I'd bought online to see whether or not they were functioning, or if they even were the chips that I'd bought or had been rebadged. And also it gave me an opportunity to learn about Arduinos. Hadn't looked at them at all in the past. I learned a little bit about the I2C interface and GPIO extenders. So I had a bit of fun getting the circuit designed in EasyEda and then having the PCBs made up. Getting a PCB made up last time I had a go at it was done with a pen which marked out the bits of the copper that you didn't want etched away and then dropping the thing into a bath of ferric chloride. The results were never particularly good. So this has all been quite a revelation, really. It's been fun for me, and I hope it's been interesting for you. Thanks very much.